Hello, my name is Donya Hajializadeh and I'm from Department of Civil and Environmental Engineering at University of Surrey. One of our research interests is to understand the connectivity and interdependencies in different infrastructure systems, in particular different modes of transport infrastructure system. You may ask, what are these connections and why they're important? Our infrastructure systems, they don't exist in isolation. So in different modes of transport, that being rail to road to air to ferry, they are very much connected, which means the operation of one system, operation of one mode, depends on the operation of the another mode. And if you have any disruption in any of the assets in one mode, that could propagate to another mode of transport and have serious consequences for the operation of that dependent mode of transport. Despite the growing physical connectivity between different modes of transport, in practice, they are treated, operated, and managed in separation. To work towards resilient transport infrastructure systems, in particular in response to growing extreme weather-induced hazards, it's important to understand these connections that could be operational, logical, or physical connections, and understand inherent vulnerability because of these connections and their impact on short-term and long-term operation of different modes of transport. This is very much aligned with climate change adaptation programs, which aim towards climate change resilient transport systems. In this project, you will be looking at how operational failures, that is, any disruption that deviates from your status quo operation in one mode of transport propagates to another mode of transport. We will be looking at means of formulating this highly nonlinear and complex connections, and we will be also looking at how recovery and restoration trajectories propagate from one mode of transport to another mode of transport. This project very much builds on the lessons learned on a feasibility study that was funded by NERC. In that project, a prototype decision support system was built to integrate different infrastructure interdependencies in energy, water, and transport systems. In this project, you will be starting by building a cross-modal geospatial database that integrates the geometrical, topological, and operational functions and dependencies between different modes of transport systems. And you will be modeling the spatial and temporal patterns in different modes of transport. And we will be looking at bringing that into a resilience assessment of multi-layered system as one single system rather than a multi-independent infrastructure system. The supervisory team for this project will also include Dr. Sue Hughes, who is a reader at the Department of Civil and Environmental Engineering at University of Surrey and has over 20 years of experience working with local government on strategic transportation planning and advancement of sustainable transport systems. You will be also working with Dr. Cinzia Maggiore, who is a technical leader at Jacobs and has extensive experience on large and complex asset management projects such as the Heathrow expansion program. So on top of working with the University of Surrey, you will be directly working with Jacobs and interact with asset management and business intelligence team members who will bring extensive experience in transport asset management in practice. So what do you need for this project? On top of the enthusiasm and motivation for this project, we're also looking for individuals with engineering-related degree. That will be anything in transportation, civil, environment, or if you have any professional experience in this field. I hope this video provided you with some overview of the project, and we are looking forward to receiving your application.